So first of all, good afternoon to the distinguished delegates, the experts and the colleagues. I'm very welcome you to the pavilion, to the WMO IPCC and the Marie Foundation pavilion for those attending in person, the COP. But I also would like to extend my warm welcome to those attending remotely online. My name is Ilaria Gallo. I am scientific officer in the WMO Secretariat in the Climate Service branch. We are based in Geneva, from where I'm connected today. And today I will be the remote facilitator for this event. On behalf of the WMO and the Green Climate Fund, I'm very pleased to welcome you to this side event, which is called the Climate Science Information for Adaptation. This event has been jointly organized by WMO and the GCF that since 2018 until now are partnering to provide the global community and stakeholders with access to the best available science, tools and methods to integrate climate science information into adaptation investment plans and policies. Just a year ago at the COP26 in Glasgow, WMO and GCF launched a suite of tools, including a methodology and an online platform called Climate Information Platform to assist a wide range of stakeholders for the incorporation with climate science into policy, projects, and decision-making tools and products. Today, we are going to become familiar with these tools and with the methodology, and especially explore the latest updates, the enhancements, and the alignments with the most up-to-date science on climate and climate change, including the IPCC Atlas. So first of all, I would like to give you a brief overview of the program for today, and I will introduce you to the panelists before we start. The first speaker will be Mr. Amir Delju. Amir is a senior scientific officer in the WMO Climate Service branch in Geneva. And Amir will introduce you to the WMO GCF partnership and initiatives and provide some background information about this partnership. The second speaker will be Professor Kevin Osborne from the Green Climate Fund. And Professor Kevin is the climate science lead in the GCF. He will share insight about using climate change information to support transformational adaptation, planning, and project. The third speaker is Professor Berit Armeri, the head of the hydrological research department within the Swedish Hydromet Institute, in brief SMHI. And she will be cited by Dr. Christoph Sturm. They will provide updates on the Climate Information Platform, one of the products that has been developed in the pilot phase of this initiative. And they will focus on CMIP6 and share the socioeconomic pathway scenarios and how to adapt the platform to these the latest kind of updates and advancements. After that, Professor Richard Jones from the UK Met Office and Oxford University will speak about the interactive atlas that have been developed by the IPCC Working Group 1. The fifth speaker is Ms. Margaret Chapa. She's a meteorology, forecaster, and GIS expert from the Zambia Meteorological Service. And she will present about the Zambia country's perspective, basically all the challenges and needs in accessing and using climate science information for adaptation in Zambia. And finally, the presenters and the panelists are going to answer all your questions in a dedicated questions and answer session that will be moderated by my colleague Amir Delju, that is physically present at COP. So I kindly ask you to take note of your question, and we will answer them at the end of the presentations. Just some housekeeping reminders. Please keep your mic muted for those attending remotely, so we don't disturb basically the flow of the event. So without any further ado, I will give the floor to my colleague, Mr. Amir Delju, for the first presentation. Thank you all, and thank you, Amir.
Thank you very much, Ilaria. May I request you put the slide on the screen?
Shall I do, or Gulay will do it?
No, Gulay is doing.
Okay.
Go to the cover slide. First slide. Yes, thank you. Can you change the slide, Gulay? Go to slide 1. Thank you. Today at COP, the title of the day is Finance, and we have chosen the initiative, an example, an area of cooperation between WMO and the Green Climate Fund to show how finance and science are cooperating together to serve the stakeholders and practitioners in adaptation and mitigation. Science is the bedrock of the convention and the Paris Agreement. We have subsidiary body for scientific and technological advice, which is entry point to receive scientific information to parties that guide the negotiation. Also, the Paris Agreement says all activities on adaptation and mitigation are based on science. So this project between WMO and GCF started in 2018 to provide the global community with the best available science, with tools and methodologies, and also bring together expert network that provide the best advice for adaptation project planning. Last year in COP, this project was officially launched, and we have the publication, the methodology that we presented to parties as a guideline for NAPS, a complement to the guideline. This year, the board of the GCF has officially approved, and it is the decision B3319, which paves the way for further cooperation with the Green Climate Fund. On the right side of the slide, you see what is at the heart of this initiative. There are 4 steps that we have identified scientifically required for adaptation planning. Step 1 is risk assessment, how to quantify the risk based on the context and location, how to better understand the impacts. And step 2 is climate contributing factors, which provides analysis of at least 8 climate indicators. We characterize the climate system of the past, present, and future, and link it to non-climatic contributing factors. These are socioeconomic data, which after AR6 and the emergence of shared socioeconomic pathways, now we have more requirement to better understand what are the non-climatic contributing factors, how to link it to the climate system, the physical system that we characterize. There are also new dimensions that have come into play, like demographic data, economic data. And when we put all these 3 steps together in a co-producing level with other experts from other sectors, we provide the best solution. We identify what are the best and most efficient solution for adaptation planning. The outputs of these projects are like the platform that provides downscale data for all locations around the world. It is under development to address CMIP6 products and new Cortex models. And also we have ClimPact version 3 that provides historical data analysis with 70 indices. Next slide, please. Since the beginning of this year, we have entered the 2nd phase of the project. First of all, every year we will have an annual forum that brings experts from all sectors and climate science together. This year we had 600 registrants. The forum was held in September. We also provide training to all least developed countries. The first one was held in South Africa, provided support to 4 countries. We teach them how to use the methods for historical data analysis, how to use the platform for Cortex data, how to interpret them. Actually, when we mobilize experts from around the world, the best output of their advice is interpretation of the data. Next slide, please. And the forum which I mentioned, we organized in September, presented the current state of the guidance and development of climate action proposals. We also identified the gaps Also, which models and methodologies are used and fit the best to which context? What are the gaps? We are addressing those areas. My colleagues, next speakers will go into more details to explain about the platform, about the methodologies, and what GCF is planning to do in this phase. Thank you very much.
Thank you very much, Amir. Can you hear me? Can you hear me?
Yes.
Okay. Okay, thank you very much, Amir. And now I'll give the floor to the second speaker, Professor Kevin Osborne from the Green Climate Fund. Thank you, Kevin.
Thank you very much, Ilaria, and I hope you can all hear me. If somebody could just bring up the presentation, please. So good afternoon to all colleagues in Egypt. I'm very sorry that I can't be there in person, but I'm obviously delighted that I can join you virtually. And thank you, Amir, for your excellent summary of the collaboration to date, how we've worked together to provide enhanced climate information in support of adaptation. I think noting that the same tools in many cases are valuable in plans and projects concerning mitigation as well. So if you could just move on to the next slide, please, Goulet. And I won't repeat any of Amir's introductory remarks. It's safe to note that my colleague Berit from SMHI will be saying more about the climate information platform during her talk. Can we move on to the next slide, please? Thank you. So Amir has introduced the collaboration extremely well, launched last year at COP26, and with some training already delivered. And I'm really pleased to say that we heard firsthand at the forum in Geneva, which was held in September this year, from those attending the training workshop, how these tools have helped the development of their adaptation plans. And it's great that Margaret will be speaking later in more detail about her experience. I'm going to talk a little bit more broadly about using climate information alongside complementary sources of information throughout the full cycle of adaptation. So if we could move on to the next slide, please. Thank you. So the forum, which, as we've heard, met in September, so it is represented here by the left-hand box, as Amir said, gathered international, national and sectoral experts to discuss the information required for adaptation planning and to create good proposals, as well as to identify gaps. And pleased to report here that the forum in 2023 is being planned now. And then the right-hand panel, the sort of pink-coloured box, represents the idea that we have collectively across the expert community for a dynamic online network of resources. We call it the Climate Information Gateway, providing links to everything that one really needs for good proposal development and planning. So in a sense, it's a Wikipedia of climate information. And of course, the forum will help the communities coordinate to make sure that there is only one one-stop shop, because not surprisingly, there are several initiatives about this idea, and what we're trying to do is unify those to provide a reliable and easy access source of information. So the forum and the gateway, they sort of complement one another, and we hope to begin development of the gateway during 2023. During 2022, I should say, with more and more materials being added to it during 2023. And that would include, as well as the climate information that we're hearing about today, more general guidance and training about proposal development for the GCF, as well as more sectoral and specialist material for particular types of proposal. So we can move on to the next slide. Thank you. So this slide really sort of represents the GCF process, and it emphasises the support and also the funding modes down the left-hand side there that GCF provides. And I just want to stress that what we're trying to focus on here is the complete cycle from adaptation planning, where we might use our readiness support for including adaptation support for NAPs, NDCs, and other longer-term strategies, and then with the climate information we're discussing today, adding the value that brings an idea from concept to implementation. And then the right-hand side of this slide shows how proposals reaching GCF are reviewed, but the process is very similar in many other climate finances. And the forum, as we've described before, is really crucial in that it coordinates and reviews the science information as well as the complementary information to ensure consensus on the best possible use. That's one of the goals that we've set the forum in order to promote fair and consistent reviewing certainly across the GCF's pipeline process, and I think that would apply to any other funder as well. Next slide, please. So this slide, it's a bit wordy. Please don't try and read it all. It was a decision that was made by the GCS board back in July, and it's the point I'm wanting to make with this slide is that it reinforces the GCF's mandate and the vision for adaptation. And you can see in the first bullet point there, how the GCF is committed to dedicating half of its funding to adaptation, with a focus on the particularly vulnerable, and as well to be inclusive and catalytic in the way that we promote systemic adaptation. And most importantly, at the bottom of the slide, this decision recognises and reaffirms the importance of the technical support and guidance, the kind of things we're talking about during this event, for the use of information in proposal development, for NDCs, NAPs, other adaptation planning, and to support country-driven programmes of adaptation investments. And then, of course, ultimately, in the preparation of high-quality proposals to access climate finance. So next slide, please. The next three slides, just making the point that even when equipped with sufficient information, and there is a lot of information out there, selecting adaptation options is complex. A single approach will never be able to deal with the full range of potential actions. This particular picture is from the IPCC Working Group 2 report, and it shows some adaptation options there, as you're going down, organised by the systems transitions and the representative key risks. And in this diagram and in that report, these options are assessed for their feasibility across the different dimensions that you can see across the top of the picture there: economic, technological, institutional, social, and so forth, in the near term and up to 1.5 degrees global warming. And frameworks like this provide some indication of feasibility and co-benefits, but an immediate conclusion is that there's no simple recipe for specific choices, except perhaps for the overarching principle that any such decision needs to be country-owned and country-led. And next slide, please. So in a similar way, this picture here shows the GCF sector guides, which is our advice across 10 sectors, in fact, and only 4 of them are shown in the sort of pictures on the left there. But on the right-hand side, you can see that within each of these guides are a number of what we describe as paradigm-shifting pathways, which are recognised as potentially transformative approaches. This particular slide shows some pathways for mitigation as well as adaptation. Next slide, please. And really, just to sort of, just to underline this point, this particular slide shows an analysis of adaptation options from a number of other sources, including the Adaptation Fund, the Adaptation Action Coalition, as well as the 2019 report from the Global Commission on Adaptation. I think estimated that investing $1.8 trillion US across 5 priority areas could produce $7.1 trillion in benefits between 2020 and 2030. So underlining the case for adaptation across these key areas. And you can see that these are very similar across the different reports and the different agencies, color-coded there to help you pick out the commonalities. Early warning systems. Of course, there's a lot being said about early warning systems at COP this week. Climate resilient agriculture, nature-based solutions. Next slide, please. So knowing and assessing the feasibility of options is a good start, but it's not sufficient for selection. Of course, selection is challenging because not all options can be realised because of resources, capacity. Sometimes political and economic conditions are an even more significant driver of outcomes than climate change. And although there are various systematic tools, and I think these slides underline it, there's no single tool that provides all of the information required for adaptation selection. I'll skip this slide in the interest of time, but in terms of what the GCF looks for in a proposal, the right-hand column there shows some high-level principles that have been approved by our board decision, showing that in an adaptation proposal to the GCF rather, we would look to see how an activity seeks to address current or future risk, why it's likely to be an effective response, and then explain how the activities might reduce the exposure or the vulnerability, and then finally to ensure policy alignment and the existence of good monitoring and evaluation. Next slide, please. And so these principles can be used to give a helpful framework if you sort of embed them within wider scientific context. And I think the two lines at the top there, ensuring maximum stakeholder involvement, ensuring that adaptation actions are always coordinated with economic and social development, integrated into national policy and planning. It provides a framework and a systematic approach. But recognizing that there's a significant variation in data availability, GCF does not prescribe the use of any particular data type. And one of the goals of the Global Forum that we've spoken about is to provide the advice on accessing and using the most appropriate data in the context of different sectors and geographies. Next slide, please. And this slide really just reminds us that defining the climate hazard, the exposure and the vulnerability involves synthesizing a diverse range of information, which is going to be unique for each proposal. And as well as the climate science information, we need economic and social data that underlies exposure and vulnerability, because this is just as important in formulating a good proposal. And this too will form part of the information gateway. Next slide. So adaptation planning and proposal development always needs information that's specific and relevant to the risk and to the hazard of that proposal. So I think it's obvious from this slide that a proposal that's designed to reduce the risk from extreme heat is very obviously going to need different scientific information to a sea level rise proposal or a climate resilient water security project. And building a plan or any proposal needs to seek consensus across different data sources. And the point at the bottom stresses how the IPCC encourages this distillation of multiple lines of evidence to lead to an increase in the usability, the usefulness, and the relevance of climate information, as well as enhancing the stakeholder trust. And now on to the final slide, please. Thank you. So just to finish off, I think I'd just like to say that the work that the GCF and WMO are engaged in with our other collaborators and the wider community is simply designed to equip our stakeholders with the information, the tools and the training to enable them to access and use climate science information alongside economic and social information at every stage of planning in order to improve access to climate finance, both from the GCF, of course, and from the other sources. And my final remark is that for our users, it's crucial that the information is relevant and usable. It's a user-ready final product. And this is analogous to the final mile in early warning systems. As we know, if the warning isn't effectively communicated, we don't have an early warning system. And in our context, if the climate change information is not sufficient to develop an adaptation plan or a funding proposal, then we have to bridge that gap. And one of the aims of the Global Forum is to ask the most difficult questions. But does the final product give the users and the decision makers all that they need to make those decisions? So I'll finish there, and I hope that everyone realizes from this side event that, that as a group, we intend to do more of what we've been doing. Thanks very much.
Thank you very much, Kevin. Thanks for sharing the vision and the decisions as well, and the perspective on climate science information for transformative adaptation. Now, let's give the floor to the expert speakers from SMHI, the Swedish Hydromet Institute, Berit and Christoph, that will illustrate and explain more about the already introduced climate information platform. Thank you very much.
Hello, I hope you can hear me well. Oh, it's okay. Thank you very much. Okay, yes, so we were actually contracted at SMHI for developing this climate science information platform because we have a long experience with developing warning services and different platforms for forecasting, but we also have this experience in developing climate information services with different authorities and in different contexts. So we were very happy to get this. Can you take the next slide, please? To get this assignment. And we ended up with this climateinformation.org platform. And the reason was then that there was a lot of expert knowledge out there and a lot of scientific data, but it was difficult for people, especially in vulnerable countries, who didn't have access to their own national sites and national specific data. So we developed this, and it's based on all the global information from the global climate community, but we have then designed different tools for people to make use of this data readily available and hands-on. So the first tool is this site-specific report, and this gives an instant climate change overview for any location worldwide. So you just enter your site and you will have information of changes going on in this specific site. And you will also get information on the robustness of the data so that you know what you can trust more or less, because it's based on a full ensemble from IPCC from different climate models. So you can see where the models agree, it's more robust signal, and this is reported here. So it's for any site globally. Then we have this data access platform, and this is more advanced. Here you download pre-calculated climate indicators, and you explore in different interactive maps and graphs how the situation will be also at any site across the globe. So these are two complementary tools that you can use to actually get direct access to IPCC data for your specific point, because this has not been available before, and it's not available now either. So this is a unique tool for getting the exact information for your specific site. Then the ClimPact is another kind of tool, and here you actually calculate your indicators yourself, and you get the algorithms here, and you enter your own climate information, your own meteorological time series, and you can then get the indicators calculated for your specific site and using your own data. But then you need to have access to this data, and this can be observed data, while the two previous tools, they rely on climate modeling from the modeling community. I would also like to highlight the guidance we have in this tool. So here you can actually get information on which climate information and which tools you should use at a specific occasion or for a specific question. We have a knowledge base where you have different short papers or documents describing different vocabulary and different terms that are frequently used among climate scientists, and that also specify the different data sets we have here. You also get some guidance for the different tools and how you establish a climate case. And then there are some additional resources and link to other tools. Next slide, please. So here I just wanted to show the production system that we have behind this, because you might think that when we have the climate models and we have access to the climate model data within CMIP and with higher resolution also within Cordex, you see at the top on this slide, you have those two big modeling communities that work globally, either for the global models or for regional models but within a global context, so to say. So they provide a lot of data, but this data is very difficult to use for a specific stakeholder trying to solve a hands-on societal problem. So that's why we have produced those indicators. So we produced indicators directly using the pure data from those model communities, or we have bias adjusted the data where we have looked at observations from different sources, and we have adjusted the data using different statistical methods to get a more reliable, or I should say a data set that is more similar to the one that you observe. And then we have also run this data set through hydrological impact models, because water is one of the critical issues here. Will there be too much, too little, or too dirty water? So therefore, we have used a hydrological model globally to also come up with hydrological variables for each site on the globe with a 1,000-kilometer spatial resolution. So we provide then, you see, the global data or the regional data as it is on a 2-degree or a 0.5-degree resolution. We provide it with bias adjustment on a 0.5-degree resolution, and we provide water indicators with a resolution of catchments with 1,000 square kilometer on average. And we have also published this methodology we use here in the production system, and you can see the reference to the left here. Next slide, please. Yes, and we were guided by, when we did this new climate service, we were guided by user interactions in various workshops. And you can see the red stars here is where we have had different workshops, where we have also had feedback on the system, on the content, but also on the visualization and on the data access, because people want to download the graphs and figures and the data itself in a way that is understandable. So they can have the data now as an Excel sheet, for instance, and they can have it as JPEG files. So it's very easy to get access and to download the data and to use it. And this is also how we developed the knowledge base, because we wanted to interact with the users to see what they need to know to be able to use this data in a good way when they define their problems, for instance, for the Green Climate Fund in their applications. Yes, next slide, please. So now I would like to leave the floor to Christoph to tell us a little bit about what we are doing this year on the update side, because now we are, so far we have used the CMIP 5, but now we are progressing with the CMIP 6 data, because CMIP is coming with new data sets regularly. So these kind of tools need to be filled with new data as new data is developed in the scientific community. Please, Christoph.
Thank you very much, Berit. Could you just jump one slide back very quickly? So as Berit said, all the information currently available on the climateinformation.org platform are based on CMIP 5 and Codex data based on the previous assessment report cycle. But to abide with the GCF requirement to use the best available science information, there is now a new effort to update the data in the platform with the recent CMIP 6. As Berit showed, the production of these new indicators is anything but trivial and requires a huge amount of computer power and time. So that's why they aren't ready yet. So we're now starting to work out the new version, and it is work in progress. So all the details aren't set yet. Our objective is to be comparable to data available in the IPCC Atlas, which is why we're aiming at selecting the same global climate models, so around 35 models, and to look at different emission scenarios, so the SSPs, the shared socioeconomic pathways, for certain 2.6 all the way to 8.5 as the IPCC Atlas provides, and potentially even 1.9 if we can access enough models that have run this scenario. Next slide, please. So just to get a bit more into the details about the differences between CMIP 5 and CMIP 6. First of all, there's been a couple of years, there's a certain number of years between CMIP 5 and CMIP 6. So in the meantime, The climate models have improved, included more processes and feedbacks, and they are often available at a higher spatial resolution, which is particularly relevant for the case of this project. One difference also is that the previous RCPs, the representative concentration pathways, have now been superseded with shared socioeconomic pathways, the SSPs. Fortunately, the two can be compared when looking at the total radiative forcing, which is the last two digits, so 1.9, 2.6, and so on. But there's more information now available, and this is why we aim for the climateinformation.org to jump from the previous 3 SCPs to 5 different SSPs. And the goal of the platform is not only to provide this additional data, but also to provide tools and guidance on how to make use of this increased amount of information for future climate projections. Thank you. Next slide. So we will hear a lot more about the IPCC Atlas just in minutes. But as it has established as a reference when it comes to future climate data, and will certainly be part of the climate information gateway that Kevin spoke about. This is why we're really trying to be as close as possible and as comparable as possible to the IPCC. And the similarities will be that we'll be trying to fit the same model ensemble as the Atlas, or at least a sub-ensemble that has the same properties, depending on resource limitations, and will provide this similar SSP scenarios. However, there are some significant differences between the data that climate information will provide as compared to the IPCC Atlas. One is the fact that the climateinformation.org provides bias-adjusted climate adaptation of the model outputs to be more comparable to what you actually experience in the real world. And by this process, we make it possible also to downscale statistically, so to say, so that the resolution will be available at 1/4 of a degree, which is around 25-kilometer resolution. Notice that this is an improvement as compared to the previous CIMIP 5 data available in CIP, which was 1/2 a degree. The other major difference is that the IPCC Atlas provides mainly meteorological climate indicators, whereas CIP will provide these indicators as well. But on top of that, all the output of the hydrological impact model, which covers data on runoff, discharge, but also some more detailed information about aridity, soil moisture, and so on. And I'd like to invite the audience, especially after having a look at the available data, to come with feedback on possible additional indicators that they would like to request and use for their own project proposals. Next slide. So this was basically a brief overview of the data that's in climateinformation.org and the plans we have to update this information on behalf of WMO and GCF. Thank you very much.
Thank you very much, Berit and Christophe. So now it's the time to give the floor to one of the, the developer of the IPCC Atlas directly, Professor Richard Jones from the UK Met Office and Oxford University. Just a housekeeping announcement. Please keep your presentation for the next speakers, Richard and Margaret, short and concise, because we would like to give also time for the questions from the floor. So thank you very much.
Okay, thank you very much. So I'll just go straight into the presentation. If you could have the next slide, please. So I just want to introduce a couple of innovations that we developed in the Working Group 1 contribution to the 6th assessment report before saying a little bit about the Interactive Atlas itself. So the first of these, can I have the next slide, please? Is that we developed a new set of reference regions over which to generate robust information on climate change in the context of the regional assessment undertaken in the 6th assessment report. And the key in the context of this presentation of this is that what we were doing is developing information which was relevant across these particular regions, which is very different from saying that the information we are developing is relevant at every single location within these regions. So these were regions where we were averaging the information either in terms of observed changes or future projected changes, or in the context of the report, the attribution of changes to human influence. So this is a very important point to keep in mind, the relevance of the region that we are discussing and the averaging that is taking place over that region. So can I go to the next slide, please? The other key development within the 6th assessment report was these climatic impact drivers, which was a result of a consultation between Working Group 1 and Working Group 2 to develop a series of indices or climate system conditions which were relevant to the assessment of impacts and risk in Working Group 2 to ensure that the information we were developing in Working Group 1 was directly relevant to the Working Group 2 and the assessment and the application in impacts and adaptation and risk assessment. So this is obviously very important for the context of the presentations of this session, which is regional information for adaptation. So can I go to the next slide, please? So as a result of the work we did in this in the assessment, we came up with very strong statements about human activities causing climate change, increasing extreme events, so heat waves, heavy rainfall and droughts becoming more severe and more frequent. Can I have the next slide, please? And this was summarized in this figure in the SPM, which looks at heat waves and heavy rainfall and droughts. And here we're looking at a sort of a quasi-geographical representation of those reference regions, which I introduced in the first slide. And again, the important point here is that this information is relevant across, as an average across these regions, and is not necessarily information which you can apply in every single location within that particular region. Can I have the next slide, please? We also developed a series of findings on other aspects of extremes, including compound events, and the fact that in some of these regions you are getting multiple Hello? Oh.
Hello?
Hello?
Yeah.
Okay, yep.
Yeah, I think we lost you for a while, Richard. Again. We don't hear. I don't know if it is only me. Oh.
Hello? Yes, okay, this one's working. Okay.
Okay.
Which is another important finding. So can we go to the next slide, please? That we are already seeing that climate change is causing multiple changes in every region in the Earth, and this is something that we're going to see more of as we increase warming in the future. So next slide, please. So I don't expect you to read this, but this is an important table that we have in the technical summary, which looks across along the horizontal all of those climatic impact drivers, and down the vertical all of those reference regions, and shows where we have confidence that these things will either increase or decrease in the future, and also information about whether we see observed changes and whether they can be attributed to human influence. And the take home from this
I think the microphone is bad, Richard. We cannot hear you.
Okay. Okay. And so we also have within the Interactive Atlas the ability to summarize all of the information on a particular region. And here we're looking at a region within Africa. And if we go to the next slide, please. And this is an example for a region in South America. This also shows where this feature that each individual region will have its own specific set of changes and multiple changes. And this view here shows where, in addition to what we're expecting in the future, where we have evidence of observed changes and whether those are attributed to human influence. Can I go to the next slide, please? And also the other thing in terms of the different views that we have in the regional synthesis of the Interactive Atlas is the ability to see how combinations of climatic impact drivers will change in a particular region. And now to the final slide. In addition to that, so all of those examples I was showing from the Interactive Atlas there were the ability to interrogate the summary information across all of the regions. We also have the regional information component of the Interactive Atlas, which allows us to go into more detail in specific regions of what's happening in terms of a very wide range of variables. So variables on temperature and on precipitation, on wind, and over the oceans, on ocean temperature and ocean acidity, and the ability to look at different statistics of the information, either at a particular reference region or aggregated over, say, a continental region like is being displayed here for Europe. And we also have within this regional information component both the CMIP5 and the CMIP6 ensemble and the Cordex ensemble, which allows you to see the consistency that you're getting between the different ensembles, which enhances your confidence in the robustness of the information. And here we are also able to interrogate it to see how things like the seasonal cycle of climate will change, or to look at the time series, or to look at how different variables will change with respect to each other under different warming levels. So you have a very, very wide range of information that you can you are able to look at within the regional information component of the Interactive Atlas. So that's a very, very quick run through of the main functionality of the Interactive Atlas. But I think the underlying point that I'd like to make is that all of this information is information which is relevant at the scale of those reference regions that I showed you in the first slide. So it is very useful in terms of providing the underlying context of how climate change is, how climate is changing in a region or has changed in a region. But in terms of information that is specific to an adaptation happening at a particular location, you need additional contextual information that is relevant to that specific location, in addition to what we're showing here. The power of the Interactive Atlas is that it is a tool that presents information that the IPCC has assessed in a very easy way. And so you can get that authoritative information very easily. But for specific adaptation interventions, you need additional information on top of what we're presenting here in the Interactive Atlas. So thank you for your attention.
Thank you very much, Richard, for your valuable presentation and insights. Now we just have 5 minutes, and let's see if we manage to get just pick up a couple of questions. But for now, for the last but not least speaker, I invite Margaret Chapa from Zambia. Margaret, please try to keep to be brief, like you literally have 5 minutes. Maybe you can highlight the experience with the climate science information for a climate action workshop, against what are the challenges faced by Zambia in accessing climate science information. Thank you.
Thank you very much, Ilaria, and I welcome all of you to the Zambian experience with the climate science information for adaptation. And I'm Margaret Chapa. Next slide, please. Okay, on this brief presentation, I'll just talk about the challenges and gaps, the capacity development needs and requests, then the good experiences using the climate science information. Next. Yes, the challenges that we are facing in Zambia concerning the climate science information for adaptation, one of them are the data gaps. Then we have sparse weather station network. We are also experiencing the challenges in the human capacity, and we have the institutional challenges that are due to lack of data policy to exchange data and lack of coordination with other national actors. Next, please. Then for capacity development needs and requests in terms of climate science information for adaptation and climate action, we need to expand our meteorological network. Currently, the whole country, which is about 752 square kilometers, has only 41 manual stations, observing stations. Then we have 130 automatic weather stations. Then we also have voluntary stations, which are only 500. These are the rainfall reporting stations. And for us to improve on the climate science information for adaptation, we propose that at least if we can acquire about 2,500 automatic weather stations and get about 10 upper air observation stations, because at the moment there is none. We are just observing the surface observation, the upper air. We don't have any station at the moment. And we also request that if we can have at least 5 radar stations for lightning detection network. Next, please. Yes, and again, we need technical support on data rescue and database management. For data rescue, all of our paperwork, our historical data is just lying and fading. So if we can be assisted in those lines, that will help us enhance our climate information, science information. And we also need training, especially technical training. We need experts in climate modeling to develop and generate localized and downscale and analyze climate change data sets. We also need customized trainings, especially in our ministry, which is the Ministry of Green Economy and Environment, and other sectors on the specific and different practical use of climate information. Next, please. Yes, and we also need access to climate finance. Capacity is needed in climate finance for the majority of project proposals in our proponents, most of which are all working with the government institutions, in order for us to have better projects with better chance of getting financed and enhanced capacity needed, especially in the National Designation Authority office and the technical committee. These are the people who review climate change proposals in Zambia. These are supposed to be enhanced before submission to GCF or adaptation funds. Next. Next slide, please. So we have had good experiences in using our climate science information, that is for policy making or other project proposals. Yes, the NAP, we are producing the national adaptation plans. Ours is being revised with the funds received through the GCF readiness financing. Climate change was also used to support the access of financing of the readiness project through the National Designated Authority. And that's the name of the NAP. More climate science use will be more crucial as the NAP is being revised. Then we have experience in collaborating with international, national, and local partners. The successful development of our National Development Plan for Climate Resilience and Zambia Readiness Project is done in collaboration with the government of Zambia, institutions like the National Designated Authority and Ministry of Lands, and support from Global Water Partnership, who are the delivery partner. So those are the people who are helping us to revise our NAP. Next, please. Then experience with the project proposals. Yes, most of our proposals that use climate science information usually have strong climate rationale and have a higher chance of receiving funding. And all the adaptation projects that have been funded have had strong climate science information used. This is strengthening climate resilience of agricultural livelihoods in agroecological 1 and 2. So this project was funded by GCF with very strong climate science information. Next, please. Yes, that's the brief experience of climate science information. Thank you very much for your attention.
Thank you very much, Margaret, for being so concise and clear at the same time. So with that, I would like to thank again all the panelists and expert speakers. And I give now the floor and the moderation of the event to my colleague Amir. Amir, see if you want to pick up some of the questions from the room. Thank you all.
Thank you very much, Ilaria, and thanks to all participants and speakers. I have the pleasure to inform you that Professor Celeste Saulo, the first Vice President of WMO, is here. She's also a candidate for the Office of Secretary General, has been very kind with us to attend this event. We have Mr. Ian Lisk, President of Services Commission here. We have also the permanent representative of Armenia and Director of Met Service, among other audience. I can open the floor for question, very short and quick, because we have already exhausted the time, but we can take one burning question from the floor, if any. Or Ilaria, if you have any on the chat, please tell us.
No questions on the chat, thanks.
Okay, I have one question for Richard. So if there is no question, Richard, I saw that Working Group 1 has offered 46 sub-regions, like climate zoning. I'm wondering if Cordex should also follow the same classification and zoning in CMIP 6 or not?
Okay, thanks, Amir. So the reason for the zoning there was to develop information over regions which are climatologically homogeneous, and also at a scale which we felt that the information was robust from the climate models, which range from resolutions of 50 up to about 250 to 300 kilometers. Any smaller than that, we felt that the information would not necessarily be representative. I think that there may be an argument within Cordex running at higher resolutions to refine that. I think the principle should be applied by Cordex. I think having a common set of regions where you can compare across a range of different ensembles is very useful. But I think for specific regional applications, there could be arguments for, as I say, refining that approach, keeping the same approach, ensuring that the information is representative at the scale you're averaging, but maybe having slightly finer resolution regions at a regional scale.
Thank you very much, Richard. So, yes, Professor Saulo.
Thank you very much. And thank you for all the speakers. I would like to echo the intervention by our colleague from Zambia, particularly in regards to how difficult it is for the less developed countries to prepare proposals to the Green Climate Fund. And I think that the WMO could help a lot in this issue. Also, I would like to congratulate the IPCC Group 1, because this is the first time we see the regions and can show our governments the lack of information or the lack of certainty over certain regions. And this is a powerful tool to support the increase of observation of the sampling system that we all pursue. So just this reflection. We need more capacity building so that we can access to the green climate funding opportunities that there are many, but are not reachable for all of us. Thank you very much.
Thank you very much, Professor Saulo. Yes, Richard?
Just a very quick response on that, which is that I think the example of Zambia that we heard there is a very good example. And I think what would be really nice is to use examples like that as case studies to provide to share that experience with other countries in other regions. And I think that would be very powerful to do that.
Okay, thank you. So time is over, and I close the meeting once again by thanking all the speakers and our audience. Thank you very much.
Thank you very
Thank
much,
you.
Amir.
Thank you very much.
Everybody.
Thank you. Bye.
Bye-bye.
Bye. Bye. Thank you.